Good evening, everyone. I'm assuming all my voice and sounds are working. Let me switch to my face so we can get started. Hello, everyone. I think everything's going. I've got something playing next to me, but it's 10 seconds behind, so I don't know. So anyway, I hope everyone's having a good evening. For those of you who are in the middle of the earth, to those to the west, it's probably getting late, and to those in the east, you should be sleeping. So I hope you're getting some rest instead of watching. But those who are staying up late to watch, oh, that's awesome. I see we've got some cool people joining. So yeah, let's just get that welcome slide up and we can talk about how exciting stuff that's coming up. All right. Okay, so yeah, it's November-ish. This is the November slide, but we moved it on a week. So it's technically not November anymore. It's now December. So I had to tweak the slide to slap the ish on the end. It's our 7th lockdown event. And yeah, let's just switch to the thing that I can actually change the slides. There we go. All right. We've got some people online joining us today. We've got Gergana and Alan. They are actually going to be speaking today, which is really exciting. There's me at the bottom, Vivendran. He's probably going to be tuning in a bit late. Gordon's not here today, but we do have Pomalemo all the way from his house. So that's really exciting. So before we talk about what's happening today, we've got some exciting stuff happening next week, because December and Christmas and the end of the year, we decided to have one last one, sort of a nice finish off the year, the great year of 2020, where they released .NET 5. I know everyone's been talking about that since January. Nothing else has happened this year except a single event. So that's really exciting stuff. We're going to have Scott Hanselman tuning in live from his house, I'm assuming, to talk about sort of the past, the present, and the future of .NET. You know, all the new things that have happened, all the stuff that has brought them to this. Brought everyone, you know, you in the community as well as Microsoft and the team to where they are today. So that's going to be really exciting. I'm actually looking really forward to that, to see what he's going to talk about. And not only will it just be Scott, I know it's sort of like, okay, I started with Scott. Now who else is going to be speaking? So we've got some other people joining, talking more about .NET. So that's going to be really exciting. So definitely come. It's next week, same time, same place, same URL. So you can tune in there the 9th of December. It's going to be our last meetup, so definitely I hope you guys can come join and listen to Scott talk about some exciting new things in .NET that's coming up. And before we talk about things, let's see who we're speaking today. We've got Gergana talking about how to build a lightsaber, you know, the weapon from an elegant weapon from a more civilized age. She's going to be showing us how to build our own, you know, bring back the future, I suppose. And of course, Alan Pete afterwards is going to be showing us how to automate our home in a fun and exciting way to make sure that, I don't know, when we lose our fingers, we can't open the doors or something. You know, that's always exciting. So stay for that. And with that, before we quit, after everyone's spoken, we're definitely going to have a networking event. So you can use that URL. You can come join us and just chat to the team, chat to the people speaking on. On the topics, ask questions there. You can also ask questions during the presentation. It'll be queued up. You can even have a little chat there. It's to say it's Q&A, but you can definitely use it for just saying, wow, that's amazing. Oh, I don't understand what's going on here. As some sort of two-way communication, both with your between people watching as well as, you know, the presenters. So definitely just anytime, feel free to hop on and say, no, let's talk about this. And without further ado, I'll be handing over to Gergana to teach us how to build weapons. All right. Okay, I'll put her live. And are you going to share your screen, Gergana?
Yes, I'm sharing it now. Can you see that? I'm hoping you can.
Yes.
Awesome. Okay, cool. So let's get started. For those of you who watched my last talk on the MS Doug, I this time have backup internet, so everything should be okay. All right, so around last year, close to my birthday, my husband asked me what I would like for my birthday. And We were watching a lot of Clone Wars at the time, so the first thing that jumped into my head was a lightsaber. And he just laughed, and we carried on doing what we were doing, probably watching more Clone Wars. And then a little while later, a few minutes later, I stopped and said to him, no, wait, you can't buy me a lightsaber for my birthday, because a real Jedi has to build their own lightsaber from scratch. And he looked at me and said, so you want to build a lightsaber? And that, my young Padawans, is exactly what I did. But before I can tell you how I did it, in order for you to trust me as your Jedi Master, I have to introduce myself. So my name is Gergana, but I usually go by Jerry because that's a little bit easier to pronounce. You can find me on my website and on Twitter. They're all on the screen. If you want to have a look at some of the other weird things that I build and do with usually JavaScript. I work for a company called Cora, and I am a Microsoft MVP in Windows development because of my contributions to IoT. And this whole thing started with me wanting to program this little Star Wars robot, because every Jedi needs a trusty droid to go on adventures with. And the idea here was to make the droid work with the Force. And now I know what you're probably thinking. Probably thinking, this lady's crazy. What do you mean the Force? We live in the real world. Well, we do have a Force. It's just known by a different name. We just know it as JavaScript. So anyway, lightsabers. The process you're watching right now took about 3 days. The hilt of the lightsaber is 3D printed, as you can see. Lucky for me, I have a good friend who found the model and 3D printed and painted the hilt for me. The model is based on Obi-Wan Kenobi's lightsaber, and it was created by a 3D designer for an advert for a 3D printer. And it's available free online. You can find the links to it on my GitHub. The process you're watching at the moment took about 8 hours, painting, sanding, and getting the whole thing together. The hilt itself is built from 14 pieces. It's hollow inside, so we can put the kyber crystal inside. And the blade is detachable, because the first time I did this talk, I actually had to do it in Cape Town, and I had to fly with this thing from Joburg to Cape Town. So I needed to be able to take it apart so that it doesn't look too much like a weapon. Luckily, it was around this time last year, so it looked a little bit more like Christmas lights than a weapon, so they let me through the airport just fine. This is what the final product looks like. And just because I wanted to be as cool as Rey in The Force Awakens, my lightsaber also has a screw holding it all together. Now, that's the outside. What about the inside? Well, the inside of a lightsaber is made of a kyber crystal. The kyber crystal is what gives the lightsaber its power. And back in the peak of the Jedi Order, young Padawans, such as yourselves, would be sent to remote planets to find their own kyber crystals. Now, unfortunately for us, we do live in a slightly more boring world than the Star Wars universe, so there is no such thing as a real kyber crystal. Fortunately for us, we have two things on our side. We have JavaScript and we have IoT. So my first attempt at building a kyber crystal involved something called a Nordic Thingy 52. Now, I'm not calling it a thingy because I forgot its name. That's actually its real name. And it's a little prototyping IoT kit. It's perfect for building a lightsaber because it has all of the components that we need. It has an LED. It has a speaker for the zoom zoom sounds. It has a button or also known as a dead Jedi switch, because for those of you who know Star Wars, you'll know that every time a Jedi drops their lightsaber, it turns off automatically. And it also has an accelerometer, so we can make it make sounds as it moves. The other thing the Nordic thingy has, which attracted me to it, is Bluetooth. Now, Bluetooth is my favorite wireless technology, but I'll tell you more about that later. Now, this was great as a prototype. However, there was two problems with it, why I couldn't actually use it in my lightsaber. The first one is the LED on it is not actually that bright, and we want our lightsaber to be bright. And the second one is that that block over there does not fit into that cylinder. So I had to go for something else. I decided to use a Raspberry Pi Zero. Raspberry Pi Zero is a little Raspberry Pi, a smaller version of the normal Raspberry Pi, pretty much. It runs on a Debian-based version of Linux, and it's command line only. So because the HDMI port it has is a micro HDMI port, which is more difficult to find cables. So it's just easier to SSH into it and do all of the things on there directly. The first part was the lights, because it's in the name, right? It's the most important part of this thing that we're building, getting the lights to work. I was using a RGB LED strip, and that strip is connected to the serial peripheral interface pin on the Raspberry Pi. The reason we connected to that pin rather than a normal GPIO pin is because that pin allows us to send high frequencies over short periods of time. So it makes it look like the lightsaber is glowing, and it makes it turn on and off like as if in a wave to make it pretty much look cooler. Now, there are a lot of tutorials about how to connect one of these RGB LED strips to your Raspberry Pi. And you would think that by my age, I've learned not to trust everything that's on the internet, but most of the tutorials mentioned that because there's a lot of little LEDs in this one strip, we have about 43 of them, 44 of them, it requires quite a high amperage. It requires more than 2 amps. And the Raspberry Pi cannot provide enough amps in order to power the strip. So I tried to add extra power, because following the tutorials online. And I connected everything up to an extra power source using a power bank, and suddenly I could smell smoke. I was a little bit worried. I started picking things up. At the time I was still working on a breadboard, so I was just moving wires around trying to figure out where the smoke was coming from. I unplugged everything quickly, and luckily I only lost one jumper wire, but I went and fetched a multimeter to find out why this was happening. And measuring the output from the cable I had cut in half, you know how we have these standards where the red wire is always the live wire and the black wire is the neutral wire? That's how electricity standards work. Well, in the case of my USB cable that I had cut in half and was using, that was not the case. And that's why there was smoke. So I decided to give up on what the internet said and decided that I can just plug my LED strip directly into the Raspberry Pi. It was still not working. It took me quite a while. I was reading so many tutorials. According to most of them, it should have worked. Eventually, I ended up on the Wikipedia page for what an LED is. A light-emitting diode is a component which, when current flows through it, it produces light. It's like, yeah, that's a pretty standard definition. That's exactly what it is. So I carried on staring at the page. And then I saw the symbol for an LED. And I started thinking, that triangle over there, it's not there just for prettiness. It's actually pointing in a direction, because a light-emitting diode only produces light when current flows through it in the correct direction. So I took a closer look at my LED strip. And I know if you're looking closely, you've probably seen it. But there it is, an arrow pointing to the direction in which you're supposed to connect your LED strip, and my wires were connected to the wrong end. So that took a few years of my life, but after that fix, I had lights, which was great. Next was the sound, the zoom zoom sounds. Now, unfortunately, a Raspberry Pi Zero does not have a sound card on it. However, because it has an HDMI port, we know that it can produce sound. Well, in order to fix this problem, I got this little sound card. This sound card fits exactly on top of the Raspberry Pi Zero. They fit quite well together. It's the same size. And you just install the drivers that you find online when you Google the sound card's name, and you have your sound. The only problem that I had here came a little bit later, but the reason sound works on the Raspberry Pi Zero is because it's connected to a pulse width modulation pin, which is actually also a GPI open, but I'll explain a bit more about this in a moment. Then there was the button. Buttons, as far as components go, are supposed to be really easy. Buttons are on or off. They're a 1 or a 0. The switch is open or it's closed. Simple, right? There are a lot of different GPIO libraries out there in Python, JavaScript, a whole range. And all you need to do is switch between the 1 and the 0. Unfortunately, as I mentioned earlier, the PWM pin is also a GPIO pin, and the drivers for the sound card make it into a PWM pin. Now, there are certain pins that can be transformed into PWM pins. The GPIO 18 that you see pointed out over here, or pin number 12, that is a specific PWM pin. But now, some of the other GPIO pins on the Raspberry Pi are also affected by the transformation of the PWM pin. This is not documented. I haven't been able to find anything on it online. I just know that if you pick the wrong GPIO pin for your button, then your sound won't work. So the one I ended up picking at first was the wrong one. But eventually I figured out that if I move to a different pin, it all works. So luckily there's quite a few GPIO pins to choose from. Now we have lights, we have sound, we have a dead Jedi switch. The last thing we need is the accelerometer. And the accelerometer was actually the easiest part of this whole thing. There is only one place you can connect the accelerometer. It's the inter-integrated circuit, or the I2C bus. There are two, they're labeled both on the Pi and the accelerometer, and you can only plug it in one way. There's no other way to plug it in, and it just works. This part was super easy. We have the inside our Kyber crystal, but now we need to write some code to make our Kyber crystal work. One of the most common things that people ask me when they say, when I tell them I built a lightsaber, is what color is your lightsaber? Well, the truth is your lightsaber can be any color you want it to be, as long as you can connect it to the internet. I decided to use Bluetooth for this. Now, as I mentioned earlier, Bluetooth is one of my favorite wireless technologies. The reason for this is because Bluetooth isn't like Wi-Fi. Wi-Fi is reliable. Wi-Fi works over long distances. Bluetooth, not so much. I mean, Bluetooth 5 is supposed to work at a distance of 4 kilometers. while the longest recorded distance was 400 meters. That's quite a big difference, right? That's only 10% of the actual what it's supposed to work at. It's a little bit of a weird technology. I think that's why I like it so much. Now, in order to understand how we connect to our lightsaber, I have to explain to you some of the weird things I know about Bluetooth. So let's start with Bluetooth devices. There are two types of Bluetooth devices: central devices and peripheral devices. A central device is something like your computer or your cell phone. It's the smart device in the connection. It's the device that initiates a connection and tells the peripheral what to do. All connections work from central to peripheral. There's no central to central or peripheral to peripheral connections. Then the peripheral device, in our case, that would be our lightsaber. In other cases, it would be things like your headphones, your Bluetooth headphones, or your heart rate monitor, something like that. So what we'll be building today is a peripheral device because we're building the lightsaber. Now, in order to create a peripheral device, there are a few things that we need. We first need a GATT profile. The GATT profile is a set of generic attributes that define the Bluetooth connectivity in a hierarchical data structure. Every Bluetooth device has a GATT profile. GATT profile consists of one or more services. The services are the behaviors of the device. So, for example, if we think of a heart rate monitor, it would have a heart rate service. Each service has connections to other services as well as one or more characteristics. The characteristics are the actual functions of the device, what the device can actually do. So, again, heart rate monitor example, heart rate monitor would have a heart rate characteristic or measure heart rate characteristic. There are three types of properties that appear on characteristics that define how those functions actually work. There's a write property. The write property is when the characteristic allows the central device to send data to the peripheral in order to tell it to do something. So we'll see an example of a write characteristic in our lightsaber a little bit later. The read characteristic is the other way around. It's the one where the central device will ask the peripheral for some sort of information, and the peripheral will send that information back to the central device. In our heart rate monitor case, the heart rate measurement would be a read characteristic because you can't tell the heart rate monitor what your heart rate is. You can only look at what it is. And then there's the notify. Similar to the read, however, it repeats on a constant basis, notifying the central device of what that characteristic's value is. One thing that's interesting about the notify characteristic is that it only works while there is a central device connected to the peripheral. So when the central device disconnects, the notify characteristic stops. So there's no broadcast of characteristics without the central device that's listening. In order to build the Bluetooth capabilities into the lightsaber, I use the library called Blino, or Bluetooth Low Energy for Node. It's a Node.js library installed using NPM. Important thing here, if you are using JavaScript libraries for all your GPIO or peripheral things on a Raspberry Pi, you must remember that you must always run it with sudo npm install sudo node everything, because otherwise you won't have access to those peripherals. Now we're going to build two characteristics into our lightsaber. The light characteristic will be the right one, so we're going to tell the lightsaber what color to change to, and the notify characteristic will be the button one, so the lightsaber will tell us whether it's on or off by notifying the state of the button. So let's get started. First thing we're going to do is build that write characteristic. So we extend a class from the Blino characteristic. We give it a universally unique identifier. This is a 128-bit string that you assign as a UUID, and we give it the properties right. There are two. There's one method we have to override, the on-write request. So when the central device sends a write to this characteristic, we read the data, which comes in a buffer. So we read it as an unsigned integer array. We read the values for red, green, and blue, and then we set it. The last important bit here is the callback. So we have to send a callback to the central device to let it know that the write is completed. Otherwise, that just stays open and the central device won't actually know that it's finished. So we either send a success or an error. Next, we have our notify characteristic. So similarly, we extend from the Blino characteristic class. We create a UUID and give it the property of notify. And then we override a few more methods here. The first is unsubscribe. So this is the part I was talking about earlier, where it will stop broadcasting when the central device stops listening. So unsubscribe, we save this update value callback so we know that there is something listening. On unsubscribe, we clear it. And to send the notification, we check that callback and then put the value into a buffer. Buffer in this case of size 2, because it could be just 0 or 1. That's the only values it can take. Then there's two other things we need to do for our button to work. We have to have a start, which checks if the button's value has changed and then sends a notification, and a stop that stops everything from running. Now we have our two characteristics. Let's move on to wrapping them inside a service. Now, as far as services go for Bluetooth devices, usually you're supposed to group the things that are similar together. So in our case, because both of our characteristics are I/O related, it makes sense to group them into one service. But in the case where you have more characteristics, you might split them up into different services. So we're only going to create one service. To create our service, we first initialize our characteristics. Now I know I said there's only two, but the third one there that you see is called surprise for a reason. Then we start the button one. So we start the notification process. Remember, even though we're starting it, it won't notify because there isn't anything subscribed to it. Our function to create a primary service looks like this. We create a new Blino primary service, we give it its own unique identifier, and we give it the 3 characteristics. Then we set the services and add a console.log just for debugging purposes to figure out if something goes wrong. And last thing we need to do is now wrap this into our Bluetooth profile. So in order to do this, we listen to 2 events. The onState changed event. This is what is happening to the actual device we're using. So if the device has been turned on, then we need to start advertising. So we're going to start advertising a Bluetooth device called Lightsaber with that primary service unique identifier. Now, if you were in the same room as me, if you turned on your Bluetooth right now and searched for Bluetooth devices, you would be able to see Lightsaber in your list of available Bluetooth devices. When that event fires, we listen for advertising start, and advertising start calls that create primary service function we spoke about earlier. Any other state, and we stop reading the button, stop advertising, clear the intervals, just clear everything up so that so that we can stop the Bluetooth functions of the lightsaber. And that is how we built our internet-connected lightsaber. Now, I know that you all actually came here to see my lightsaber, and this would have been a lot cooler if it was live, but let me try show you my lightsaber. Just back up a little bit here. I hope you can see this. And because it's Bluetooth connected, we can connect to it using this website over here. It's just going to scan. Is it taking so long to scan? Come on. I can also do this from my phone actually, because this one is not going to work. Okay, let's just open up the website. Of course, the demo gods failed me. Okay, let's try this. So, usually I ask people to vote for what color, but since we're all online, I'm just going to change the color and hope for the best. And as I said, any color you want it to be. And for the surprise characteristic, because who wouldn't want a rainbow lightsaber? Put that down before I hurt myself. Thank you very much. Are there any questions? Can't see Teams.
Well, thanks for that. That was really cool. I was watching the code. You know, it just looks so simple when someone else puts it all together. And it's like, yeah. Wait, why haven't we all got a lightsaber? I think there was one question. Someone asked, Ben asked, I wonder if a microbit would have worked for this project.
Yes, actually. So I did explore some other ones. I haven't looked at the microbit too closely, but one of the other ones I looked at was an ESP32, which is kind of similar to a microbit a bit, and also a Nordic NRF chip. I looked at both of those. The reason I chose the Raspberry Pi actually is because JavaScript is easier than C, to be honest.
Oh, that's the truth.
Yeah.
Okay. Any other questions? Oh, question popped in. Okay.
Stop sharing there.
Okay. All right. No, thank you very much. That was really exciting, and I always want to build mine. I've got all the breadboards and all the bits and pieces to do all of this, you know. And I always like, you know what? I do it some other time. I've got to learn some stuff. You know, let me write some code here first. One day I was just get all this IoT stuff and just do it. You know, I've got all the different variants. C, I got some C# ones, and I got, you know, obviously I can write some. I've got a Raspberry Pi, I think, as well. It's somewhere on the shelf. That's just lying there.
So that's one of the things, like one of the reasons I actually started doing everything in JavaScript is because when you also have a language barrier to do this stuff. So if you don't know the language you're supposed to program the thing in, then it becomes more complicated. Yeah. So yeah, that's why I don't do C very much, because like I don't know enough of it, you know, to be able to do it.
Like if people were interested in getting started on, start with IoT for this type of project, where did you start? What was were you following a tutorial? Were you following a blog, or whatever?
Yes. So actually, because I had there were so many issues I ran into along the way. I actually documented a lot of the process. So I have a bunch of blog posts on like all the different parts of building the lightsaber. So if you go to my website, you can check them out.
Okay. All right. Oh, well, thank you very much. And one more questions? Someone, Ben asked again, is JavaScript becoming a thing for IoT?
So actually, I found that it works quite well for IoT for a lot of the projects I've tried because it's quite fast. Although a lot of the libraries are compiled C libraries in order to work for IoT. So if you know C, I think it would be easier. But like if it was JavaScript or Python, either one would work.
All right, thank you very much. And I will be handing over to Alan. If he can share his screen, then he just fix pop-ups over there. Stop that.
Okay, let me see if I can share something.
Just gonna wait for Alan to get home automation. So now when Jerry wants to break in with a lightsaber, he can protect himself with some sort of locking system.
Okay, let me just share the screen.
Oh, I don't see anything.
Just hang on. Let me just share it.
All right. Technical difficulties. Where's that? I closed the. I had a slide that we've specially created for situations when. Let me see if I can find it while we wait for you to error. Connect.
Okay. Let's share. There we go. Do you see my screen?
Right. Yes, I do. Sending you live. There we go. All right. Take it away.
Oh, yeah. Well, thank you very much for everyone that's attended. Jerry, that session was awesome. I'm not sure how I'm supposed to follow that. But yes, I'm going to try. I'm not sure how well I'm going to do, but that session was really awesome. Okay, so I'm going to be speaking about IoT and home automation. So it's an extension on what Jerry used in her talk, and I want to make it fun for all. So I'm looking to make what I'm going to do accessible to everyone that wants to learn how to do IoT as well. So hopefully it's going to be fun. Let's see how it goes. Okay, so before we start, who am I? I'm a Microsoft MVP. I build stuff every day on the Microsoft stack as a day job. I'm lucky enough to basically have my passion as my day job. So I build like lots of mobile apps, and my favorite thing, and I'm going to punt it today as well, is Xamarin for mobile development. And I also build IoT things for fun, and also build IoT things for my day job as well. So it's really fun things to do. If you ever want to contact me, my Twitter handle's there on the bottom right. It's ADP'd if you use Twitter. And if you want to email me, adp'd@gmail.com. Right, so my desk looks like this. I build like weird and wonderful like toy devices to play around with things. These toys also then become prototypes for a lot of the IoT projects that we do. So you can play around and then actually earn some money out of it as well, because you'll find that a lot of these toys are really sophisticated and things. and helps you with actual implementations. But also what people say is a desk is a reflection of somebody's mind, so it might be a bit scary in this head of mine, but yes. And I took a photo of my desk today just to show. I'm really proud of this desk. It's the most professional it's looked in a long time. Right. Okay, so what is this talk about? So it's all about making Internet of Things accessible to everyone. So an easy approach to start out, something that everybody wants to play around with is automating their house because it is the in thing. Smart buildings are becoming a thing, but using just your house to learn how these IoT devices work and how to connect them to the cloud and things like that is a good way to start. Like Jerry was building Lightsaber, that's helped her learn a lot of things. Just take something in your house and play around with it. Switch on a light, switch on anything, and see how it works, and learn how to build things from there. And of course, you can get more complicated than that, but you can start off really simply. So this talk will be including a platform from Azure known as IoT Central. It will be using something called Node-RED. And we will also be looking at something like known as low-code IoT devices that you could use quite easily off the shelf. Right, so before we start building something for our house, we need to look at architecture. So of course, being a solutions architect, I bring out my diagrams, my block pictures and things like that. So what we're looking at here is at the bottom is my house, on the top is the internet. I want to have an application connect to things in my house. So for this demonstration, I'm going to use some lights and I'm going to use an aircon. It's a very cheap and nasty aircon that I'm going to be using, but bear with me, it's just a demo. But when you're designing something, you probably don't want to have your application connecting to like switches and things in your house and switching things on directly. So what we might want to do is have some sort of layer in between. We could use something in the cloud that could be a buffer between an application and between an application out there and of course our own home internet and our own home devices and things like that. Something that runs MQTT is probably a good idea. That's message queue telemetry transport is the explanation of the acronym, but we will look at that a lot as we go through this session. And then of course we've got our switches to switch things on, switch on the lights, switch on the aircon. In this example as well, and this session, we will be looking at a little air quality monitor. The reason why I also introduced an air quality monitor into my house is because during COVID, I'm sitting in an office. I'd like to know how quickly I'm going to die. So it would be quite nice to know the quality of the air, what's in the air and things like that. So we'll be looking at that as well. Right, so fleshing it out. We have the Cloud Hub, which is doing something known as MQTT, and then into my network. I don't want to have every device necessarily connecting to the internet. I want to have an intermediary in between the devices and the cloud. So that's normally known as a gateway. So in other words, a gateway, an entry into your network. So thinking of this architecture, we can put in a gateway of some sorts, which then interacts with our switches. And then thinking of making an implementation of these things, we could have something known as IoT Central, which will handle the Cloud Hub and MQTT. Our gateway, we could look at something known as Node-RED. We could, and this is quite nice for the architecture within your house, is have your own local MQTT server as well. That, of course, when the internet goes away, you can still use everything in your house because you don't, it's best practice not to have everything relying on internet being there, especially especially in Africa, where internet is not always available and not always good. You don't want to have something that goes rogue and you can't switch it off. So I introduced into the architecture within my house something known as Mosquito. Mosquito is a local MQTT server as well. So what you could also do is bring in some off-the-shelf applications, like something like Home Assistant could be like a user interface as well to the things in your house, and then interact with your switches and things like that. Home Assistant, I suggest you have a look at it for automating your house. It's out of scope for what I'm going to be speaking about today. I'm going to be speaking about, and seeing this is a dev group, we're going to be speaking about how to DIY or hack it together or build it yourself. And what we could do is add applications that can be speaking to this architecture, which could be something like Power Apps, which interacts with IoT Central, which then relays to our gateway and switches things on and off. Could be a mobile app that you write, could be whatever app. It could be, if you have an app, you could remote control when you're out of your house and you just relying on the internet to speak to your house, or you can do local control. So in other words, where there's no internet, you can control the devices using your local MQTT server. So you do get off-the-shelf air quality monitors, but I really like this little device. This is known as a Pimoroni Enviro Plus. It actually is a hat, so it's a Raspberry Pi hat. It's also running a Pi Zero, as Jerry was using. So behind that hat is actually a Raspberry Pi Zero, but it's a really cool device. So it's a temperature. It has a temperature sensor in it. It has a pressure sensor. It does humidity detection. It does light detection, proximity as well. So in other words, when I move close to it or enter the room, it can detect proximity. It has a gas sensor, so it can work out what gases are in the air as well. And it also has something fancy known as a particulate matter sensor, which detects particles in the air as well, which is, especially if you're asthmatic and things, you don't want to have particles in the air. So it measures that as well. So these are really cool. They're also quite cheap. You can buy them from Pimoroni. So the URL is there stuck on the hat there in the front. You can actually shove these in every room as well if you want to monitor different rooms in the house. It's a really cool device. And it also gets, it also originally got me to exercise my Python. So what I've got is an implementation using Python, and it will be running in the session today, what's known as an IoT Central firmware, which is just a fancy word for it reads from sensors on the Raspberry Pi and then relays them to IoT Central. So in other words, it's a sensor to JSON converter is the fancy description, or the not so fancy description of a firmware. Right. So I mentioned that we will also look at how to integrate some low-code IoT solutions. So you can buy these Sonoff devices from any electrical shop. You can get them from Takealot in South Africa. Pretty much most shops sell these things nowadays because they're like a commodity item. What the devices are that we will use today as well is just switches. So those are relays which switches on things that use high current and of course work on now 220 AC power. And those have the ability to switch things on and off. And what's really cool about them is they connect to Wi-Fi, so we can control them with Wi-Fi. They also, some of them support radio transmission as well at 433, the 433 radio transmitters. So you can use remote controls with them as well, and little clickers like you use for your alarm systems. So these are really nice devices. They're also low code IoT because they just work. So it's also a very nice place to start with IoT. They also support MQTT, and they're supported by a firmware known as Tasmata. Tasmata is really cool as well. It's an open source firmware. It also disconnects you from the manufacturer's things and what they want you to do and things with the devices. So it's a really cool thing to have installed. And once you have Tasmata installed onto these devices, you can then have like it acts as a web server as well, so you can connect to it directly. You can switch it on, you can configure it, and set it up and things. We'll look at that as we go. Right, so you can, just the downside of this, but also the fun part of this is Tasmata, you have to flash these devices with. So in other words, flash is upload the Tasmata firmware to the device. There's some tutorials to do this on the internet. There's a link at the bottom that you can follow to do this. I use the Raspberry Pi to program mine, but you can get a USB, what's known as a USB TTL cable to do that as well. And what you just need to do is hook up a couple of GPIO pins on the Raspberry Pi if you're using the Raspberry Pi, and then basically run a little app on the Raspberry Pi, and it will transfer the firmware to the device. Something that's cool about this is you only have to do it once. Once the firmware is on the device, it keeps itself up to date with over-the-air downloads of later versions of the firmware as well. So you only have to do this once, but it's really fun because you get to do some real plugging in of wires and things. If you notice that device there on the left, in the first couple of these devices, I actually soldered a header to the board and was very professional about it and things like that. So the headers, those pins that's coming out the board. And then you see the one on the right is like, I got tired of being professional and soldering things and found it just works fine if you shove a wire in a hole or a pad on the PC board, and it just works. And you just have to hold them in the right angle. It works fine. So you don't have to have any sort of soldering skills. You just need to be able to put a wire in a hole and off you go. Right, so something that's really fundamental to the setup that I've got in my house is everything runs over Docker. So Docker is a container platform where you can run things known as images and container images. It's really nice to get up and running with your home automation setups. I actually have Docker running on a Raspberry Pi, which is this picture here. It's got a big heatsink, so you know that's a Raspberry Pi 4 because it runs really hot. But it's very capable of running Docker containers and things like that. So it's a really cool machine. So I suggest you look up, if you're not familiar with Docker, just go to docker.com and have a look how to get that up and running. But the very important thing when you're getting started with these Tasmata devices is probably install this Tasmata admin. You can find it at Docker Hub. And what's really cool about this is it discovers all these devices on your network and you can manage them in a portal, which is really cool. The important thing is when you run these Docker containers, once you've pulled it from Docker Hub, the only thing to bear in mind, and that's going to hold true for every one of these Docker installations that I'm going to show you, is just map a local folder on the Raspberry Pi to your image, because of course when your image shuts down, you don't want to lose your configuration. So these volume mappings here, so like the /home Ubuntu Docker, is basically just a folder that I've got which stores the configuration information. So this Tasmata is really cool. It gives you basically a dashboard of all the devices you've got plugged in. So these are the 3 devices I'm going to be looking at in this session. And what we've got here is just showing you, we've got some office lighting, we've got my aircon that I'm going to hook up. And it's also showing you things like the version of the firmware and things like that, and what their names are and things, and what the power usage is on the device as well. So you can also switch.
Alan, something went crazy with the sound.
Oh, that's probably my aircon firing off. Is it better now?
It was like as if someone was drinking. Yeah, it's better now, but it was like someone was listening right on their throat. Okay, that's good.
Okay, well, that was the aircon switching on. Right. So if I drill into this, it shows me what type of module I've got. So I've got the Sonoff Power R2 module, which is a nice module which can switch things on and off. It also gives me the power that the device is using as well. So I can switch things on, I can configure them, I can set up what the module is. So yeah, I've set it up as a Power R2 module. I can set up the important thing, which is the MQTT server that it's connecting to. Also important things to note that all these things use topics on a queue. So here we've got the topic set up as a Sonoff Aircon. Matthew, I'll warn you next time I switch it on. Right. So you can also set up a whole lot of other things. These things are also automated timers as well, that you can get it to switch on lights and things at certain times. So if you go on holiday, you can get it to automatically switch on and off without having an app involved and things like that. So it's really powerful. And this is basically Tasmata offering a web page and stuff for configuration. Right. So the other thing I've got running is that a local MQTT server. It's called Mosquito. It's basically Eclipse Mosquito. And again, if you set it up with Docker, it's easy to get up and running. But you just need to remember to map the configuration settings and things like that between Mosquito and your local Raspberry Pi. Yeah, so all these things that I've shown you, I've been deploying onto a Raspberry Pi. I'm using this for a demo. It will work fine. I used to run with it for many years and stuff on a Raspberry Pi. It's cool. But seeing I got myself a NAS as well, and all these things run in Docker containers, my production, my fancy name for my own home automation system is actually running on a NAS. But if you've got a PC as well, and any machine that can run Docker, you can run it. And of course, you don't really need Docker involved. Docker is just nice to get all of this stuff up and running quickly. Right. So yes, as I pointed out, you can use this Tasmata with MQTT. It's the main reason for using it. The other reason is these devices, these Sonoff devices that you get, they use something known as WeLink, and it connects to the mothership outside your house. I don't like that. So this Tasmata is quite nice because everything that you do runs locally. Right, so now we also introducing a cloud implementation. So we're looking at Azure IoT Central, and the cornerstone of Azure IoT is what's known as an Azure IoT Hub. And the IoT Hub establishes communication between devices in the cloud, and it's bi-directional, so it's two-way. So the cloud can speak to device can speak to cloud. It also implements cool things like that MQTT protocol that you can put messages on a message queue and they can be picked up. And they also add the important thing that's missing from most IoT implementation, and that's security. I'm not sure how secure Jerry's lightsaber is. I hope it's very secure. Right, so Azure IoT Hubs, this is the architecture of it. You have endpoints for device to cloud, cloud to device. On the left is how it connects to the device. On the right is how it connects to the cloud and hands off to the rest of Azure. And you can also have gateways. So if a device doesn't support maybe TLS 1.2 to the cloud, you can have a gateway. So maybe a RS485 device that needs to connect to the internet. It can't connect to the internet, so you can use a gateway for that. Another very important thing of these IoT hubs is managing of these devices. So you could have 1,000 devices out there. You need something to manage it. And what these IoT hubs do is they give you the management on top of that. And of course, they work with everything that's every SDK for every platform out there. So you can build whatever you like on whatever platform. There's an SDK for that, which is pretty cool. So I'm in one of my devices, I'm using a Raspberry Pi Zero that's running Raspbian. But those son-off devices really are just ESP8266s. So of course, those devices could also speak to IoT hubs as well. Right, but when it comes to this building an IoT solution with IoT hubs as your cornerstone, it becomes really complicated, really fast, because you need to think about how to scale the things, how to hand off to systems to visualize streams, and of course you need to real-time process streams, and a lot of times you hand off to something like known as Power BI to visualize and things, and then that becomes complicated because you need a user management system to who can see what and things like that. And you want to then have different storage mechanisms, data transformations and things like that. So it becomes very complicated very fast. So that's where the platform known as IoT Central comes in. And what it does is it makes it fast and easy to implement. So you don't need to have all that architecture expertise to put all these components together and have them work. It's something known as software as a service for IoT. You don't need any cloud expertise to get it up and running. So it's a really nice place to start, especially if you're using the Azure platform. It's scalable and secure because it actually implements, and it's enterprise grade because it implements that reference architecture that you saw as well, so that you don't need to, which is the less you do, the less you can get wrong. So it is a good place to start. So these are the other offerings in the IoT space from Microsoft and Azure. So we've got IoT Central, software as a service on top. We've got something known as an IoT suite, which is lots of offerings together to get you to an endpoint fast. And at the bottom are the building blocks that was in that reference architecture. There's also something known as solution accelerators to get you up and running quickly. So if you want to extend your house into maybe a factory someday, it's basically quick solutions that's out of the box that you can just roll out a full IoT solution. We won't be looking at that today. Right, so I mentioned Node-RED, and this should make Jerry very happy because it's JavaScript. So it's built using the Node.js implementation. But what's really cool about this is, and really cool for me, I don't have to code JavaScript. I can drag and drop things in a flow designer and things magically happen, which is really cool. So this is a low-code programming environment, and it's made for event-driven applications. So in other words, messages coming off my MQTT message queue are events that's happening, and it's able to react to those events quite nicely. So it's drag and drop. It supports that MQTT, which is my cornerstone of my architecture that I did in those pretty little diagrams previously. It supports Azure IoT, which ticks a box. It supports Tasmata out of the box as well. It's really cool. And it's really nice to get started because you don't need that barrier of learning JavaScript to get up and running. You don't have to learn Python to get up and running, or C# or any of the other languages. So this is also a good way of starting up. It's also a good way of testing IoT solutions as well. As mentioned, it supports Azure IoT. It has out-of-the-box connectors for it. Supports the son-off devices straight, so I could put a son-off device down and I can speak to it. In this diagram here with the on-off is basically a son-off light, and I can inject on and off and switch on like that. And it supports MQTT, so it can read messages from a message queue, and it can put messages onto a message queue in a really, really easy way. To get it up and running, I've also got this running on my little Raspberry Pi. You can install it also from Docker Hub. Also, just do a pull and run it, and just remember to map the data folders, and off you go, and it'll be up and running. Okay, so Node-RED can also act as an IoT Central gateway. And I'll show you in a demo later how that all comes together. But it's really cool how you can map flows from the cloud and distribute them to your devices that you do have. Okay, so let me show you a bit of what I've been talking about. Yeah, right. So I mentioned IoT Central. I've created an IoT Central app. So this is an empty app that we're looking at as well. So what we've got is the ability to create dashboards. We've got the ability to run analytics on systems. We can run rules. So in other words, if some sort of telemetry needs to trigger an alarm, we can set up rules for that, which is all nice and drag and drop configurable. The main part of IoT Central is your device, and of course your IoT device, which is the reason for this platform being. So what we can do is start off with creating a device template. So a template is what a device looks like. So what you do in IoT Central is you model a device, and you do that visually. So what I'm going to do, I don't have any templates here, so I'm going to create a new template. And what it does is it starts guiding you into how your device works. So either you have a cloud-based or cloud-only based IoT device, or you have an IoT edge device. So IoT edge device is a device that can be fully self-contained without the cloud, and it can run, and you normally have an edge device where you need to make real-time decisions rather than waiting for cloud latency. So IoT Central supports those devices too. It also supports something known as IoT plug and play. So those familiar with Windows, where you just plug in a device and it works, because Windows has a device definition manifest to explain to Windows how a device works in a standard way and makes it plug and play. IoT also now has that as well, so it solves all the problems of complex devices and plugging them in. So there's an endless list of plug and play devices that you can connect as well. But what I'm going to do is I'm just going to create an IoT device. I'm going to say next. I'm going to say, well, let's create our air quality monitor. I'm going to say next and create that. So remember, this is my little Raspberry Pi Zero air quality monitor. Just so that you don't have to watch me model it, what you can do is I've got a pre-built model that I created earlier. So what I'm going to do is import that. Let me go here. And it's a Pomerode Enviro Plus. And what I've done now is imported a model that explains to IoT Central how that device works. It might sound complicated, but it's not at all. So all we do is we model the information that will come back from the device. So here we've got all those nice things that I mentioned before: temperature, pressure, humidity, all those gases, and this PM1 and 25 and 10 is the information coming from that particulate matter sensor. So what you do is you basically model what's data that you'll be interacting with. You can say if it's telemetry, you can say if it's a command, in other words, some code that you can execute and things like that. Right. And what makes this like really cool and powerful is it also has dashboards. So you can configure per device dashboards or generic dashboards across many devices. What I'm going to do is get IoT Central, because I'm lazy, to generate me a dashboard. So based on that information, that model that I've got of just the input fields that's going to be displayed, I can generate a view. I can tell it to generate the dashboard. And what we have is it's now generated from that information all these pretty little graphs and little indicators and things. It's quite clever to work out what you want, because this is probably exactly what I need. But you can drag and drop your own dashboard as well. But I'm not going to do that. Okay, so another cool feature of these templates is seeing the template defines what your IoT device looks like. You can have it versioned as well, so you can have different versions of templates as well. So as your device changes, you can make it version 1, 2, 3, and it'll manage all those templates for you, and you can roll those out to specific devices as well, which is pretty cool. Trying to do that manually is with experience say, it's quite a mission. Right, so I'm going to publish this, which means I'm going to make it accessible as a version, and it's going to be version 1. And if I go to devices now, I can go to my template I just created, and let me create an instance of that template. So those that know some code, you write a class that defines how something works, and then you create, when you use it, you create an instance of it. This is very much similar to that. Okay, so I'm going to create an air quality monitor. I'll leave the names by default, and I'm going to go create.
Alan, I think your screen is backwards.
It's whoa.
I was like, what? I was wondering what happened.
Whoa. How did that happen? Let's go.
I thought it was like, you're loading something. I was like, no, wait, it's too long.
Did it only start now?
It was relatively recently. You were showing the slides. You were there.
Yeah. So hopefully you didn't see all the slides backwards.
I was seeing there you're showing the text boxes out, then it flipped over when you went to the dashboard.
Okay.
And you clicked views.
So let's have a look here. Okay, let me just see if I can sort this out.
Oh, where's the technical difficulty sign I can put up?
Oh, yes. Babe. Put up that technical difficulty sign.
Finally got a use for it. All right.
Wonder how that happened.
There we go. Maybe there's like on like in video or something just to flip it horizontal, or maybe.
Yeah, no, this is a.
Okay, yeah, we missed the creation. You see exactly when it went wrong on the feed. Yeah, it's when you were creating the new one, edit view, creating a new view.
Okay.
That's when it went bad.
Okay, so what I'm going to do is I'm going to share just the screen that I'm working on. What you'll have to just put up with a little bit is a flip screen when I show you the camera.
Okay.
Okay. Right. So let me get Teams back. There always has to be some sort of technical difficulty. So I'm going to stop sharing that.
What happens if you just share your screen again and then maybe that was it?
Yeah, so what I'm going to do is just share it directly. Cool.
Okay.
Right, so let's go.
Unless Teams flipped it for you. It's no button in Teams to flip. Flip camera.
Okay, right. Are we back?
Yes, we are. All right. Live. Yay.
All right, sorry about that. I'm not sure. There's probably a hotkey I pressed that switched OBS backwards. But yes, sorry about that. Right, so what I've done is I created a template, and I've implemented the template as an office quality monitor. And here's our dashboard that was generated, which is looking quite nice, but it's waiting for data. So what I can now do is let me connect the device to this IoT Central. So I'm going to go here. I've got my funky terminal. Hopefully you can see it. Just warn me if anything flips again, Matthew. Right. Yep. So I'm going to connect to my EnviroPi. Okay. I'm going to go to this environment folder. I'm going to go nano. I'm just going to now edit this file this Python file. I decided to do this in Python. You can. Right. So the important thing is what we're going to do is connect this device to IoT Central. So it needs a device ID and it needs a device key. So I can ask IoT Central what that is. So I'm going to just copy the device ID here and I'm going to paste it in the device ID. And I'm going to get this shared key. So you can also connect to these devices in different ways. You can use a SAS key, you can use certificates, but I'm going to use the SAS key just for now. All right, so let me go over here. I've got copy that across. My scope ID looks correct, so I'm not going to copy that. Okay, cool. So I've now configured my device. I'm going to save it very carefully, and then I'm going to just run it. Now, what you would generally want to do as well is make this run when your Pi boots. So that of course when if your Pi needs to restart or something like that, it actually does. Okay, so I've run this Python file. It should now be connecting to IoT Central. Let's see if it actually does. Okay, it's connected. Okay, so we've got some telemetry happening there, which is pretty cool. Always a good sign. Now, if I go to the device and I can go look at this raw data, what I've got is some telemetry coming in. So here's the temperature. Here's the pressure, here's the humidity. It might take a little bit of time to stabilize. It's definitely not that cold here. So this is the information that is coming in. Right. When there's enough information, it will of course start graphing this. So what I'm going to do is just leave it a little while and let it pre-populate. But while I'm about it, I'm going to now create my next device. So let's start with those Sonoff devices. Okay, so I'm going to create a new device based on a template, follow the same pattern that I had before. I'm going to create my Sonoff Power R2 device. I want to read, the reason why I'm doing this, I want to read some telemetry off that device. Okay. What's nice about it, those Power R2 devices, they give me current information, voltage information, and things like that automatically out of the box. So what I can now do is I can go here. I've already modeled my Sonoff device, and what it's got here is the fields that comes out of that. So it's a power, current, voltage, reactive power, and apparent power, and things like that. I can go here again. I can generate the view. So Matthew, if this was backwards last time, this should now be forwards. Okay, I've also generated some views on that. So now I can display the output that I want. Okay, cool. Let's publish that. Let's create an instance of that device. Okay, so go devices. Let's see how air quality monitor is doing. Okay, cool. Right, still modeling. Okay, cool. Right, so I'm going to now create a device. I'm going to say, well, create a Sonoff R2 device. I'll leave it like this for now. And let's go have a look at the device. Same pattern. I'm going to go to this connect, get the information that's needed here. But what I've done is I've got this application that's open now, which is known as Node-RED. It is that nice drag and drop environment where you can start manipulating and modeling also devices and how your devices interact with things. So what I'm going to now do is just go to this flow here, and I'm going to just explain what's happening here. Is I've got this son-off aircon device, it's this little component here reads from a queue, so that Tasmata device is hooked up already to a MQTT queue. What I can also do is do some translation as well. So what I can do is I'm mapping it puts its information in a JSON energy node. I'm removing the JSON energy node because my device is looking at that. I haven't modeled it to look like that. So this is just an example of mapping. What's important to IoT Central is it needs a topic to tell it what it is. So I'm adding a topic of telemetry. IoT Central also supports commands, and it also supports properties. So properties is more information about a device. It might be some settings as well on the device. But in this case, I'm sending the telemetry, which is the voltage and the current. And we've got these little things, a little debug information. But what's cool is we've got a Azure node here, which is the Azure IoT Hub node. And what it can do now is connect to a IoT Hub. So same pattern as before. I can go copy the device ID. Oops. I can go copy the device ID, paste it in here. I can go here. I'll grab the key again because we're using the SAS key. And there we go. This scope ID looks right. So what we've got here is all the connection information that we need to connect to. It supports IoT Central as well. So IoT Central needs this DPS or device provisioning service. So it supports that. And what we could also do is call methods if we had methods and things like that. But what I'm going to do is now just say done. And I'm going to say, well, let's enable that flow. And there's a big red deploy button. I can now deploy it. And I can have it now deploy as a runnable service. And the way this all works is you model your flows and you deploy it, and of course it'll forever run, which is pretty cool. There's also this debug item here. So if I go to this little bug here, I should start seeing telemetry coming off this device, which is apparent power, reactive power, and things like that. So we have that working. Yeah, so we've got some telemetry flowing here. Right, so let's go and have a look at what's happening here in IoT Central. If we go to raw information, we're seeing some telemetry coming in. So we've got things known as total power, apparent power, reactive power, and things like that. So now we're reading the telemetry that is coming in from the device. Okay, right. So while I'm about it, let me go create my gateway. So same pattern as before. IoT device, create a custom device. I'm going to go here and say, well, this is just the name I called it before. I'm going to create my gateway. My gateway is there so that I can switch things on and off. So remember, in my diagram, I wanted to create things individually. So here we go. I've got my home office gateway. So the difference here is instead of having telemetry come in, I've got this thing that says command. In other words, I wanted to do something, and I've got these commands that's called turn gateway device on and turn gateway device off. And I can go in here, and what's nice about this gateway that I've created here is I want to create a way of switching devices on and off, but not individually for a lot of devices. So what I can now do is I can say, well, turn gateway device on, and I can pass in a parameter. So I can say, well, switch which device on. So I can give it a name. So I could say, well, switch on the light, switch on the aircon, and things like that. Right. So command is when you actually want to run something. So let me publish that as well. Okay. So let's create an instance of that. So let's go. Well, let's create our gateway. Yeah, I'll just leave it by default. You should actually make them nice, pretty names. Okay, so let's do that. Okay. Right, so same pattern as before. Let's do our connection to this. Right, so where's my gateway? I've got this nice gateway pattern that I've developed here. Let's connect this device while we're about it. So let's grab this device ID. Device ID. Let's grab E. And the difference here is we executing direct methods on the device. So we've created two methods, and those methods are the commands that comes in from IoT Central. So I can turn gateway device on, turn gateway device off. Okay, so let me enable that device as well, because I have it disabled. So it's enabled, and then deploy it. And no. Okay, so this nice little indicator says here is connected. So what this is doing in essence is it takes in a command from IoT Central. What we've got is some flows here where I can say, well, take the output of this device, take the topic, if it's a command, and take it through this flow here. And I can put it into another flow and say, well, and this you can see in code is like an if statement. I can say, well, if it's turn gateway device on, use flow 1. If it's turn gateway device off, use flow 2. So in other words, flow 1 is device on, flow 2 is device off, and this is just a function. So I can basically say, well, my device's name is based on a topic, and this payload is the parameter that I send in from IoT Central. And the important thing for this is the message that I'm going to push to the next node is this one, and this next one is my MQTT server. Oops, don't do that. Is my MQTT server that's at Mosquito, and that'll get an on message to that topic by name. If I do the off, the important thing is same name. However, it tells it to switch off. So now I can switch a device on and I can switch a device off. Right, so if I go to IoT Central and basically say, and now let's see if I can repair my damaged OBS. Let's go to camera. Let's see if we can get the camera just to appear. No, close OBS. And then Matthew, you'll just have to explain if this works or not. Camera.
Got my eyes on it.
Okay, so I'm not using my fancy screen sharing, so I'm just using the camera straight. So what I've got here is on the left is that EnviroPy, which is reading the temperature and telemetry and stuff. And what I've got is my aircon, and that big noise that you had before was this thing spinning, right? So if I had to just, and let's just do manual screen manipulation. So we can do that. Who needs OBS? Right. So I can send a message as well to a device. So I've got this thing called Sono aircon, and this is a command that I can call, and I can pass in that parameter name that I've got, and this happens to be the same name as that topic that I've got. So if I run,
it happened.
I probably should do very quickly and switch it off. And what I can also do, seeing that it's a nice gateway as well, I can say, well, switch on the light. So what I could do is I can switch on the light. I've got this big red LED light as well that's switching on. So hopefully it's apparent and not reversed, things like that. And what I can do is I can send a message to switch it off. So what's happening there is quite cool with this node red. I didn't write any code. So these messages are just coming through, filtering through, and I'm passing it through onto MQTT. And of course, the Tasmata device just knows if I see an off, I'm going to switch off, and if I see an on, it must switch on. So you can model things quite nicely without actually needing some code. Right, what are these devices doing anything with this? Yeah, cool. So remember we mapped our Sonoff Power R2 device. So this device here is reading from that aircon I switched on. So I switched it off very quickly because apparently it makes a noise. But you notice that we've got some nice graphing happening here, and we got some telemetry coming off that, which is pretty cool. So there you've got just an off-the-shelf device that we've mapped. All it needs to do is map fields, and of course the device sees these fields and displays it, and you can do stuff with it in IoT Central. Let's have a look. Where's the other one? And this is our air quality monitor that we've hooked up. So it just needed some time to catch the telemetry coming off it. So what's quite nice is we've now got our temperature and humidity, pressure, and light that's displayed here. And the temperature in the room, the air pressure, and all those type of things automatically coming off IoT Central. So this is really cool to get up and running quickly. If you notice, I didn't really do much. I just drew some pretty pictures and I told IoT Central to sort itself out. So this is really powerful and really nice to get started. It's just a note on it. You can also get 2 devices free running on IoT Central as well. There's a device charge that it is charged per device. Seeing it's a software as a service model, they've basically monetized it like that. But if you do things like this, and don't tell Microsoft it says so, if you do things like gateways and things like that, you can control lots of devices with one entry. And of course, if you keep it to 2 devices, you can run this permanently for free. So Matthew, I didn't say that, but it's an internet tip.
What was that? I heard you say we can sell lots of licenses. That's what I heard.
Right. Okay. So now let's just back to okay. Right. So that was just a very quick demo of those platforms and how they all come together and things like that. But now, of course, you can hook up apps to it as well. So different types of control systems and things that you could build yourself. I see Dustin's not here today, but we have a understanding that we cannot have a talk without demoing a Xamarin app. So we have to build a Xamarin app, but it's really simple to hook these things up. So what you've got for local interaction with your local MQTT broker is nice libraries that you can get from NuGet.org. There's system.net.mqtt, and literally all you do from an app perspective, be it a Xamarin app, be it a JavaScript app, be it a Python app, is put that message on the MQTT bus and say like light on or light off and stuff, and magic will happen. And of course, if you want to communicate not locally, but via the cloud to your device and go through my whole route for the gateway and stuff, you can use Microsoft Azure devices. That's just that's part of the Azure IoT SDK, and that package will get you the communication to IoT Central as well. So if I do this and I go to Visual Studio, let me run this. So I'm going to quickly run a Xamarin app. This app here happens to be a Uno platform app. It's just a framework that you could use when building a Xamarin app. You could do this, of course, as a Xamarin native app. You could do it as an Android Studio native app as well. You could do it as a Xamarin Forms app. Anything that makes you happy, there's an SDK for any of those options. Right, it's running later. Let's go to the emulator. It's now, of course, on the wrong screen, so let me go fetch it. And then Matthew just warned me if anything's in reverse. Cool. My makeshift OBS. And okay, so what we've got here is an app. If I go turn the light on, I get my wonderful red glow. If I switch this on, I'm going to make everyone deaf, which is that. Switch that off. And so we've got interactions happening from a native app. So of course, being a native app, you can speak locally to MQTT, or you can speak via the cloud as well. Right. If Power Apps are your thing, there's connectors as well for Power Apps. So there's a premium connector for IoT Central. It also supports Logic Apps, Power Automate, and Power Apps. If you go to the link at the bottom, you'll get everything that you need to know about those connectors. Power Automate is very simple. It will automatically infer from IoT Central what those commands are. So here we've got execute a device command, and it will pick up that those commands that we've configured in IoT Central automatically, and you can then pass it also parameters, and these parameters is basically where you can fill in Power Automate as a parameter to switch on which device. So in my case, the light or the aircon. If you want to build the equivalent of the Xamarin app in Power Apps, there's Power Apps canvases. There's of course a connector that's the same connector that's using Power Automate, and you can then rapidly create a drag and drop user interface. Power Apps, for those that don't know, it's Microsoft's low-code solution, so you can literally build this without any code. And in this app here, it's basically just when I press the light on button, it calls a Power Automate flow. You can build these things really quickly. Okay, so just something to note, if you do want to get up and running, some of this is not so well documented, so you can use the slide as documentation. You need to switch on some experimental features within Power Apps. There's an enhanced formula bar you need to switch on. You also need to switch on something known as dynamic schemas. And the reason for that is everything that comes out of IoT Central, seeing that you can model it visually, is dynamic. And of course, Power Apps is not really good at handling dynamic things. So they've added some new features specifically for this connector. And they are at the moment experimental features. But if you go into the settings, just switch these two switches on and happiness will ensue. Right. So the enhanced formula bar as well, you can put in the methods and things like that you want to call. So this is part of the V3 API. This is the method to get the telemetry. So you can go devices get component telemetry value, and you just basically speak to the device ID, and you'll see that that's my Pimoroni environmental sensor. But what's different to the normal Power Apps formula bar, it's added this capture schema as well. So capture schema, it looks at the information coming back from IoT Central, and it makes a schema which defines that dynamic data that comes back. It's very important that you switch that on, otherwise you can't call the V3 API from Power Apps. Yeah, and that's me for this evening. Thank you very much. I hope it was useful. It's a very whirlwind tour of IoT, and hopefully we will see lots of IoT solutions. Yeah, is there any questions?
there was a couple of questions. Yes, Ranesh, the settings will be shared on the same link on the meetup, so you can just follow that again. So there was a question.
I'll switch on my camera to show off my shirt.
Oh, yes, there's the shirt. I think we should start a Teespring thing for that, so we can distribute it. Use the sales to cover the cost of food or something. Ben wants to know, how do you solve Wi-Fi dead spots? When he's talking about Tosmato, everything's connected. Like, how do you solve dead spots? What is the more routers, access points?
Yeah. So yes. What I've done is in my house, it's a double-story house as well, so it's got a double problem of multiple floors. So what I've done is I've got a couple of routers distributed around the house, and I'm using something known, well, I'm actually using Asus routers specifically, and they've got something known as AI mesh that kind of sorts itself out with the Wi-Fi connectivity. But yeah, the simple answer is more routers or repeaters at least.
Okay, and I suppose this also was answered by the thing I didn't hear. Now, what's the cost for regular users? And as you mentioned,
so what it adds up to is like 40 cents per device that you've got. So it's 40 cents as in US dollars. So it's about 6 Rand per device that you add. 2 are free, and then 6 Rand per device. But it's really good to get you up. The question was IoT Central, right?
What's the cost of using Azure IoT?
Yeah,
I'm assuming it's IoT Central.
Yeah, so seeing it's a software as a service platform, they charge you per device that you add. If you use IoT Hubs as directly, there's a free option as well. But of course, you then start adding the costs of adding additional services on top of it. So when you head to the that full reference architecture, it starts costing a lot of money, even though there is a free option on the hubs as well. So IoT Central will cost you about 6 Rand per device. But what's nice is you get a solution up and running quickly. And then if scalability is a problem for cost-wise, when you start hitting like 1,000 devices and things like that, then you'll be smiling because you can then probably architect your own system for that, for the amount of devices you're using.
Okay. And also sort of on the line of Wi-Fi sort of dark spots is what about power failures or other sorts of, I'm assuming for the gateway inside your home, because obviously the cloud doesn't have a power failure.
Yeah, well, that's just a standard problem that you need to have some sort of battery backup if you want it running permanently. UPSs, inverters, and things like that. I've got on this server, because my house is triggered by or controlled with that NAS, and that's running on a UPS. But just remember, each of these devices, like the Sonoff devices, need some sort of power. So you need to think about every device that you want to have up and running. So think about which is those that's important to you and put those on a UPS or battery backup.
Unless you have like a separate circuit in your house that powers all the switches.
Yes, yeah. So one of the solutions that most people have is like an inverter, and you can plug the inverter with a big array of batteries into your house, and it automatically will switch over. And of course, solar is a good option if you don't rely on ESCOM.
I suppose the thing is, like, you have no power. You don't have to worry about whether lights can turn on or off. And the aircon, even if you turn it on, nothing can happen. So
it's like a bigger problem if you don't have power. Yes, but everything that needs to run, you need to have some sort of battery backup.
And then
the important part of that is not really the power, it's the internet connectivity. So that's why I always suggest that you need some sort of way of switching those things off locally than rely on internet, because you've got more chance of having no internet than no power.
And one last question from Daniel is, have you done anything with like RoboGuard beams, like trigger lights when a beam is triggered and things like that?
I assume it's those garden beams that you've got, those 4 alarm sensors. So what those things can work on is also 433 radio transmissions, and you can get a hub that converts that to Wi-Fi. So, and then you can connect it to your whole solution that I showed. So I've got a couple of those type of things running with just the RF transmitter to Wi-Fi. So that actually also can address some of your Wi-Fi dead spots as well. That might use those RF transmitters. You can run those a good couple of 100 meters, and if you put them on we've got a solution on a farm. If you put it in a tin, they go for like kilometers.
And
like a Pringles tin.
Okay, is that just to sort of focus and extend it? Okay.
It focuses the basically line of sight beam. Amazing.
There we go, people. You can wrap one of your aerials in your Wi-Fi router with a tin and point it directly at your laptop.
They are directional. So you can point the aerials in a direction.
Okay, and then I'm not quite sure if this is a joke, because it's probably not, but can I use microwave radiation to power a device? That somehow feels very dangerous. Like,
probably
unless
yes,
it's like,
but I didn't say that you could. And sign the disclaimer.
That won't be like for your light switches. That'll be like maybe some long distance communication or something, you know.
This is not a question I want to answer.
Let's not open our microwaves to power our light switches.
No, definitely not.
Okay, right. I don't think there's any other questions. Probably gonna wait a second for the feed to catch up. But yeah, that is no. Thanks, Alan. That was really, really awesome. Showing off, especially with the let's step even away from code, and we got the drag and drop. Jerry was showing us, look, she wrote some JavaScript. We were like, we don't even need that. So even lower barrier.
I was using JavaScript there, so that's. Hope Jerry noticed I was using JavaScript.
It counts.
Okay. All right. All right. I think that's. Do you have anything else to say, Alan? Any last parting words before we show some slides?
No. Well, thank you very much for everyone that attended. And just is my screen still shared?
It is, but I'll put the thank you slide up now, so it'll be.
Yeah. So I was just going to mention the submitted talk. If you've got something interesting to say. But yeah, thank you everyone for attending, and thank you Jerry for that talk as well. That setup you got there is pretty cool.
And also next week, just again a reminder before we, Scott Hansen is coming, so definitely get in on that. Take a moment to just block off that on your calendar, and come here. It's all about .NET and new things added. So it's probably going to be mobile, cloud, and web and stuff like that. So definitely tune in to see that. As Alan mentioned, you can submit a talk for next year. Please do that. We want to hear some more awesome stuff. And one last thing before we go, we're going to head over to the networking event. Come along there. It's a free for all. You can join in, chat to people. Jerry and Alan, I'm sure, are going to be there, and all that sort of things. And yeah, so I'll pop over there now and have a good rest of the evening, folks, and morning if you're in the west, or morning now in the east, and late evening in the west. All right then. Cheerio, everyone.